Hello students, welcome to my presentation on reinforced concrete structures. Outcomes of today's lectures are: on completion of today's class, the student will be able to define what is a concrete, distinguish between plain cement concrete and reinforced cement concrete, knows the ingredients of RCC, explain the functions of a reinforcing steel, and states the codes used for design of RCC elements, and states the loads to be considered while designing the RCC elements. Now, concrete structures have become very common in civil engineering constructions. In this, the concrete has established as a universal building material because of its high compressive strength and adaptability to take any form and shape with resistance to the fire and corrosion. With this background, I will define what is a concrete. Concrete is a construction material, as we know that it is a composed of cement, fine aggregate, coarse aggregate mixed with the water, which hardens over the time with or without admixtures. Generally, we take fine aggregate as a river sand, coarse aggregate as a gravel. By adding all these ingredients like cement, fine aggregate, coarse aggregate with the water, then will form a mixture. After hardening that, it will become a concrete. And this concrete are basically two types. One is a plain cement concrete and second one is a reinforced cement concrete. Now we'll discuss in detail about plain cement concrete. Plain cement concrete, it is abbreviated as a PCC. This PCC is a hardened mass obtained from a mixture of cement, sand, gravel and water in definite proportions. Means here the ingredient used in the plain cement concrete is similarly the ingredient what we are used in simple concrete. That is cement, sand as a fine aggregate, gravel as a coarse aggregate and required quantity of water. And these ingredients are mixed together to form a plastic mass. The plastic mass means it's a fresh state of a concrete. This plastic mass can able to take any shape, and this plastic mass harden on setting and will get a PCC. The hardening of this plastic mixture or a plastic mass is caused by chemical reaction between cement and water. When if you cast a beam by using PCC, and if that beam is subjected to any loading, then that beam has two zones. Above the neutral axis, the zone is called a compression zone, and below the neutral axis, the zone is called a tension zone. Because of application of load, this beam will fail in tension because the PCC is very strong in compression. That means it has very high compressive strength, whereas very weak in tension. That means it has very little tensile strength. Due to its low tensile strength of PCC, it has a limited use in construction. Further, we can use PCC at many places where good compressive strength and weight are main requirement, and requirement of a tensile stress are very low. And applications of PCC are we can use under a footing as a impermeable layer. Generally, footing is laid over a natural ground, but natural ground is one material and footing materials are different material. In between these two, we'll place a plain cement concrete to make it impermeable. And it can be used under the grade slabs, and by using this PCC, we can lay cement roads. Next, we'll discuss about reinforced concrete. Why this reinforced cement concrete come into existence? As we have a problem with PCC, that is the PCC has very low tensile strength. To improve the tensile strength property of a concrete, then some sort of reinforcement is needed in which can take care of tensile stresses developed in the structure due to the applied loads. The most common type of reinforcement is in the form of steel bars, which are quite strong in tension. The reinforced steel bar is placed in the forms and fresh concrete is poured around it, then it will form a solidified composite mass. This solidified composite mass is called a reinforced cement concrete, that is called a RCC. Yes, RCC is a composite material because we are using here two different materials. One is a concrete, another is a reinforced material, that is called a steel. The steel reinforcement provided in the form of steel bars, they are placed in the tension zone of the structure to take care of tensile stresses developed in the structure. As RCC has a versatile construction material which is strong in compression as well as in tension. The use of reinforcement in the concrete not only increases the strength but also in preventing temperature and increased stresses. Means when the temperature variation takes place, then the member subjected to the RCC member subjected to a tensile stresses. And sinking stresses occur when a freshly mixed concrete is going to dry over a time. In that time, the volume of that section will going to reduce. At that time, the section will be shrink. Then the shrinkage stresses are developed. They cause a cracks. The shrinkage stresses and temperature stresses cause the cracks in the member. The RCC has many uses. Some of the important uses are listed below. The reinforced cement concrete can be used in construction of a residential building or commercial buildings, flyovers, construction of tanks, construction of road and rail bridges, and construction of chimneys and towers, construction of retaining walls, and construction of bunkers and silos. Yeah, RCC has its own advantages over material like timber, steel, and wood. The first advantage with the RCC is strength. Our RCC reinforced cement concrete is very good strength in compression as well as in tension. And second advantage with this RCC is it will durable. It has a durability property. RCC structures are more durable if designed and laid properly. And by using, if you use a proper construction practices, then RCC structure will become more durable. And modulability means it can mold into any shape when the freshly mixed concrete will be molded into any shape. It will be more useful for architectural requirements. So, a ductility. The steel reinforcement imparts the ductility to the RCC structures. Here, the ductility means elongation of a member. Means when it is subjected to loading, when it is subject to tension forces, the steel bar will elongate. It will very useful in the RCC members because as elongation, as a result of this, it will give enough warning before failure of the section. It is very economical because RCC is very cheaper as compared to steel and pre-stressed concrete, and it will be fire resistance than steel and wooden structure. Steel and wooden structure will easily catch the fire as compared to RCC. It has a good permeable property or permeability means the ability of the material which cannot allow the flow of water into it. So I can say the RCC is almost impermeable. The single drop of water will not enter into the RCC member. It has a seismic resistance. The properly designed RCC structures are extremely resistant to earthquakes. And finally, it has advantage. It can be easily transport. The raw material required for the preparation of RCC like cement, coarse aggregate, fine aggregate, steel and water, they are easily available. They are easily transported from one place to the another place. So we have some disadvantages of the RCC as RCC structures are heavier than the structures of material like steel, wood and glass. And RCC need lot of armor like centering and shuttering to be fixed. Thus, it required lot of side space and it requires a skilled labors. And concrete takes time to attain its full strength. Thus, RCC structures cannot be functional immediately after construction like unlike your steel structures. So these are the few disadvantages. Now we'll discuss ingredients of RCC. The following are the ingredients of RCC. One is aggregate, cement, water, reinforcement, and finally admixture. This is generally optional one. If you want, if you require, we can add admixture. Otherwise, we cannot. Now we'll discuss about the aggregates. The aggregates are like sand, broken stones, bricks, or inert material. The inert material means the material or those will not react with any other materials. Those materials called inert materials. The properties of aggregates are greatly influence on the behavior of the concrete because as they occupies 80% of total volume of the concrete. That means the major portion of the concrete is occupied by coarse aggregate and fine aggregate. Almost 20% will be occupied by water and cement. The aggregate which are used for concrete should be durable, strong and hard as well as well graded. The various properties of aggregates like specific gravity, strength, toughness, hardness, soundness, particle size distribution and grading should be accompanied with IS 3025. Here we have the classification of aggregates. The classification was made as per IS 383 1970. These aggregates are classified as two types. One is fine aggregates and coarse aggregate. The definition of fine aggregate is like this. The aggregate which is passing through an ISU of 4.75 mm gauge. Those aggregates are called fine aggregate. Simply say the aggregate which has a size less than 4.75 mm. Those aggregates are called fine aggregates. And next, the definition of coarse aggregate is here the aggregate which are retained on an ISU of 4.75 mm gauge. That means simply we can define the coarse aggregate is the size of aggregate which are having 4.7 greater than 4.75 mm. Those aggregates are called coarse aggregate. Here the nominal maximum size of the coarse aggregate shall be as large as possible, but it should not be limited. It should be limited to 1/4 of the thickness of thinner member. 1/4 of the thickness of the thinner, that is minimum thickness of the member. Right. The fine aggregates is to make the mixture workable and uniform. The fine aggregate also help the cement paste to hold the coarse aggregate particles in suspension. This leads to the plasticity in the mixture and to prevent the possible segregation of paste and coarse aggregate. Next ingredient of a concrete is cement. As we know that the main function of cement in concrete is it will act as a binding material. That means it will bind the aggregates, coarse aggregate, fine aggregate and with reaction with the water. Right. As we know the science or history of the cement, how it manufacture and what are the ingredients are required to prepare or to manufacture the cement. So it can be obtained by burning of calcareous, siliceous and argillaceous material together in a definite proportion at high temperature and grinding the resultant clinker into a fine powder. That itself a cement. Generally, ordinary Portland cement, that is OPC, is commonly used in construction. Here we have some different types of cement and their uses as per IS 456-2000. Those are like this. We have OPC, that is ordinary Portland cement. It can be used for all general concreting works. A second one is rapid hardening cement. It is used where rapid gaining of strength is required, that is where road works and repairs. Sulfate resisting Portland cement. It can be used for marine structure foundations in sulfite bearing soils. Next one is PPC, means Portland pozzolanic cement. Generally, it will be used for all building works, mass concreting works, and marine structures. Hydrophobic cement, it is used in construction of swimming pools, a floor for food processing plants. And next type of cement is high alumina cement. It will be used for marine structures. Next, quick setting cement. It is used underwater structure. Super sulfate cement. It will be used marine structures as well as construction of sewerage lines. And following some of the tests are conducted on the cement. The tests are fineness test to know the fineness modulus of the cement, consistency test to know the consistency of cement, setting time. Here we have a two setting times, initial setting time and final setting time, and we can conduct the test on that is a cube cement mortar cube, that is a compressive strength and soundness strength. Generally, the OPC is available in three grades, that is 33 grade, 43 grade and 53 grade. And here the number 33 will represent the strength of the cement, right? That is grade. What is the definition of grade here is, grade is the strength of the mortar of 1:3. In this, 1 proportion cement and 3 proportion sands are mixed and they will form a cube of a side 50 mm, and those cubes are cured for 28 days. After that cube is tested under the compressive testing mission, then we'll get some strength. That strength is not in terms of MPa, or we can say Newton for mm square. Here the grade are designated with a 33, 43 and 53. 33 nothing but that is the strength of a 1:3 cube of a side 50 mm. After curing for 28 days will attain the strength of 33 Newton for mm square. Generally in our country, cement is supplied in the bags of 50 kgs and the equivalent volume of one bag is equal to 34.5 liters. As per IS 456-2000, for a RCC construction, for 1 cubic meter of concrete, will use 450 kgs of cement. Next ingredient is water. To have the proper chemical reaction in the concrete, the concrete should require 25% of weight of the cement used. That means if the cement is 100%, in that by weight 25% of weight of water should be added. The water is used in the concrete during the mixing and after casting of the concrete member also, that is for curing. The water which is used for both mixing and curing, that should be free from injurious amount of oils, acids, alkalis, salt, organic materials and other substances that may harmful to the concrete or reinforcing steel. Generally, we'll use potable water for satisfactory mixing of the concrete. As for IS 456-2000, the pH value of water should be more than 6. The reinforcing material. Next ingredient is reinforcement. The concrete, as we know that concrete is very weak in tension and it is to be reinforced properly with a suitable material. Then what is the purpose of providing a reinforcement in reinforced concrete, cement concrete? The first and foremost purpose is to take up all the tensile stresses developed in the structure, to increase the strength of the concrete section, and to prevent the propagation of cracks due to variation in temperature and due to reduction in volume, that is shrinkage stresses. And as PCC is very strong in compression, and if you prepare any concrete section with the PCC, we have to make a larger section for withstanding the load. Now in that PPC we are providing a reinforcement in the tension zone. Now our section will become stronger in compression, stronger in tension, so that we can reduce the section. We can reduce the section of the member, RC member, so that by providing reinforcement in the section, we can make thinner section compared to the plain cement concrete. What is the criteria for choosing reinforcing material? So for if you want to choose a particular material as a reinforcing material, it has to fulfill some criteria or some requirements. Those requirements are here. It should develop a perfect bond with the concrete to transfer the load or to transfer the stresses. And it should possess the high tensile strength. And it should be cheap, easily available, and should be durable. And the quotient of thermal expansion of reinforcing material should be nearly same as that of concrete for obtaining good composite action. What is this composite action here? When a concrete RCC member is subjected to changes in temperature, sometimes it may elongate or sometimes it may contract. So if the thermal expansions of reinforcing material and concrete, if one and the same are nearly equal, they elongate simultaneously and they contract simultaneously. Because of that, there is no harm to the section. If you use different quotient of thermal expansion materials, then the material with higher thermal expansion will expand more and the material with lower thermal expansion will expand less. So there is a variation in expansion, so there may be a chance of failure of a concrete member. So that's why we have to use the reinforcing material should have the thermal expansion same as that of the concrete. And it should be workable. Workability means easiness of doing with that, easiness with handling with that particular material. That means it is easy to cut and easy to bend and easy to join. And finally, the material should not react with the any other ingredients of RCC. By considering all those criteria, the material which is fulfill all those requirements, that material should be chosen as a reinforcing material. So many traditional materials such as bamboo, natural fibers have been tried as a reinforcing material but still found to be the most appropriate because it was fulfilled all the criteria, all the requirements which are earlier discussed. The reasons for providing the steel as a reinforcing material is it is strong in compression, tension as well as shearing torsion also, and it will develop the good bond with the concrete. It has a ductile behavior. Because of ductile behavior of the steel, it will expand. As a result of that, because of expansion, it will give the enough warning before collapse of the structure. It is easily cut, bent, lifted, welded with the available tools and machines, and the steel is easily available in market and has a longer life compared to the other materials like bamboo and natural fibers. The next is type of reinforcements are used as a reinforcing material. Generally, we have here few types of reinforcing material, that is mild steel plain bars, HYSD bars, hard-on steel bars, TMT bars and CRS bars. The mild steel plain bars, the designation of or the grade of the mild steel plain bars are Fe250. The properties of these bars are conforming to IS 432-1996 Part 1 in cold worked mild steel bars, and if the for a hot rolled mild steel bars, the properties of these bars are conforming to IS 1139-1996 Part 2. And next bars are HYSD bars, means high yield deformed bars, high yield strength deformed bars. That is the grade of those bars are Fe415 and Fe500. The property of these bars are conforming to IS 1786 and 1979. Next one is hard drawn steel wire fabrics. The properties of these fabrics are conforming to IS 1566 1967, and these TMT bars and CRS bars are latest version of above. This is the latest bars, they are high strength bars. TMT means thermomechanical treated bars and CRS means corrosion resistant steel bars. Here only few companies are manufacturing these bars like SAIL, Steel Authority of India, as by order. The properties of a reinforcing steel. The first one is characteristic yield strength. The characteristic yield strength of a mild steel bar or a Fe250 grade steel, it is can be calculated with respect to the minimum yield stress. This minimum yield stress is corresponding to the lower yield point in the stress strain curve of a mild steel. For the characteristic yield strength for a HYSD bar can be calculated corresponding to the 0.2% of strain in stress strain curve, because for HYSD bars we will not get definite yield points like lower yield point and upper yield point. So we are not getting lower yield point and upper yield point here in this HYSD bar. So we are calculating the characteristic yield strength of a HYSD bar corresponding to the strain 0.2% in stress strain curve. And the Young's modulus of these steel bars are 200 kilonewton per square millimeter square, and density of steel is 7850 kg per cubic meter. In market, generally we can buy or purchase this steel in terms of kgs, tons or quintals. The admixtures. What are the admixtures? These are the materials which are used to modify one or more properties of a concrete in plastic state or hardened state. The purpose of providing these admixtures are to increase the strength or to retard the initial setting time while pumping the concrete over a longer distances, to increase the rate of strength developed at early age, to increase the water tightness in the concrete, to increase the workability of the concrete without further adding the water content into the concrete. The reinforced concrete structure. Now we come into our actual topics or subject, that is reinforced concrete structure. So before defining this, I will define what is the structure. The structure is nothing but a combination of a parts or a component. If you take human body is one structure. It has many components like legs, hands, eyes, nose, everything. If you join all together, then will form a human body structure. Similarly, if you take a building, is one structure. Building has many components, right from bottom to top. From bottom, foundation, column, walls, beams, slabs, etc., etc. So if you combine all these components, then will form a structure. Right? Similarly, we can define a reinforced concrete structure. The structure in which the components are constructed with a reinforced cement concrete is called reinforced concrete structures. The example of these reinforced concrete structures are building, bridges, retaining walls, water tanks, etc., etc. For designing this reinforced concrete structure, we should know what are the codes are available for design and what are the loads to be considered while designing each element of a RC structures. That we'll see the codes used in RCC design. These are the following codes. The first one is IS 456-2000. It is plain and reinforced concrete, cement concrete. It is very important. As our diploma level, we are using more 90% will use this code only for calculating or designing any RC members. And next one is IS 875-1987 by 2006. It is related to the loads. The part 1 is corresponding to the dead loads, part 2 live loads, part 3 wind loads, part 4 snow loads, and part 5 miscellaneous loads and combination of above loads. That may be combination of dead load plus live load, or dead load plus wind load plus earthquake loads, or whatever. And IS 1893 is earthquake resistance design. And next one is SP 16-1980 design aid for reinforced concrete, and SP 24-1983 explanatory handbook on IS 456-1978, and SP 34-1987 handbook on detailing reinforcement, and SP 23-1982 handbook on concrete mix design. And these are the codes which are available to design the RC elements, and we can use whenever the code is required. The loads for designing the RC element, falling load to be considered. The loads are dead load, live load. The live load also called as the imposed loads, wind loads, earthquake loads, snow loads, and we'll discuss one by one now. what is a dead load? These dead loads are mainly due to the self-weight of the structure and they are permanent in nature. Example for dead loads are self-weight of the slab, beam or column. They are permanent. As long as structure remains, that period, the weight of the slab, beam and column remains there. And it is occurs throughout the lifespan of the structure. It can be calculated knowing the unit weight of the material. If you want to know the self weight of the slab, you should know what is the unit weight of material used for casting the slab. And generally, we have an example here for plain cement concrete. We have a unit weight that is 24 kilonewton for cubic meter. For reinforced cement concrete, it is 25 kilonewton for cubic meter. And this unit weight or dead loads can be calculated as per IS 875/1987 Part 1 live loads. The live loads they are changed with respect to time. Means if the load is there today, tomorrow that load will not be there in the same place. That means changes. That's why these loads are called temporary loads. The example of these temporary loads are loads of people on the floor, machine and furniture on the floor. This load can be calculated by using IS 875/1987 Part 2. Next, wind load. Wind may blow in any direction, but in design of structure, the horizontal component of a wind load can be considered, and also consider the velocity of wind and shape or size of the building. The wind loads can be calculated by using IS 875/1987 Part 3. Earthquake loads, they are caused by earthquakes. They are horizontal in nature. They can be calculated by using IS 1893/2002 Part 1. The snow loads, they are applicable only the building which are constructed where areas of heavy snowfall. These snow loads can be calculated by using IS 875/1987 Part 4. Right. This is all about my presentation. That in this presentation we have discussed about various ingredients of concrete, types of steel reinforcement, functions of steel reinforcement, codes used in design, and loads to be considered while designing the RC elements. Here are some quiz here. Right. Let me discuss this quiz. The why is steel used as a reinforcing material? The options are to resist the tensile stresses, S. To develop the bond stress with the concrete, S. To reduce the size of the section, S. So the option is all of above. The size of coarse aggregate is, that is, options are like this: greater than 4.75 mm, less than 4.75 mm, between 0.15 to 4.75 mm, none of the above. As per definition of coarse aggregate, that is the aggregate which has a size greater than 4.5 mm, those aggregates are termed as coarse aggregates. So option A is the correct. Okay, thank you.